There we go. All right, so let's do a recap, okay? We not last week. Last week I only saw you on Monday. Is that correct? Okay, but the week before that, our goal was to learn how to do factor label, and then you would have a homework assignment to do factor label, and then you had a chance to ask questions before you turned it in, and then I gave you a certification on factor label, and then you were supposed to show yourself and show me that you can count on me. I know how to do these. And if I didn't, you could ask me to help you, and I would help you do them. And so you were supposed to get certified, which meant I can do all 5 of these problems, and I know what I'm doing. That's why my initials are on there, because you're saying, I know how to do those problems. You get it? And if you didn't, I would help you. Now, I'm not trying to say that I wasn't, maybe I wasn't as nice as I could have been, but it got to the point where I think some of you were dragging your feet a little bit, and that's my opinion, okay? Maybe I'm completely wrong. You get it? It just seemed like some of you were dragging your feet like, no, I still don't know how to do this. No, I still don't know how to do this, and you should be asking me how to help you, right? So after you got certified, you're supposed to do a quiz, and the quiz was, you can't use your notes, but you're certified, so you know how to do it. Now, so what was going to happen is, even though I thought the quiz could have been over by Friday of the week before that, we had Monday, and then some of you still didn't finish that. So that's where we're at. Is that correct? All right, so what I thought you would do is either finish it sometime that day, and I was here after school that day, or you would finish it the next day on Tuesday, even though that was a half day. We ended up not going to school that day. Remember that? They canceled that day. So here's where we're at. I still need you to finish it, and I still can give you till the end of the week to finish that. But I don't think I'm willing to take today's class period to do that, because I want to start something new, and I think we should have been able to do that. So what I'd be willing to do is, if you still didn't turn in your certification, you need to work on that, and then when you're ready, give that to me. And then I can give you the quiz, and the quiz you can't use your notes. You'd have to do that in front of me. Get that? And I will be here like every day after school. And now remember, Wednesday's a remote day, so I won't be able to do that. But you can come before school, after school, during lunch, and say, I want to work on that, and then I'll do that. But I'm going to have you do that on your own time. Even if you stayed after school last week on Monday, some of you stayed and you didn't get your quiz finished. That's fine. I'll give it back to you. And you said, I need to finish my quiz. You get that? If somehow you finished your quiz and you said, you know what, I was thinking about that. I'd like to go back and maybe relook at one of those problems. I would let you do that too. You get that? I'm looking at your faces. Are you understand that? But I do believe I've given you enough time to do this. Now I need you to spend your own time, extra time to do it. So by the end of the week, said, I will have turned in my certification, and I would do that right away if you can. And I will try to get that quiz done by the end of the week sometime. All right, does that make sense to you? Well, that puts the onus on you, doesn't it? That means it's your burden. All right. I think you should have finished by now. You didn't. So now let's just say, step it up a little bit, and let's get it finished. All right, let's take the next thing in our order of events. Let's take a look at this. We will be starting a new unit today, and we will probably go until next Wednesday. It's possible that we'd have a test on Wednesday. I'd rather not have it on a Thursday, but I could. But we have the test. Right now I'm planning on Wednesday of next week to have a test on this chapter. And then you would have a day to get that back on Thursday. And then on Friday, we'd make sure you had all of your old tests in a file folder. And if you wanted to sit around and study with people for that day, you could. If you look here, we have this whole week, and we have next week, all of next week for regular classes, 2 full weeks of classes. And then 2 weeks from today, that should be, I think, one of your harder exams because you have 2 exams on the same day. Now, maybe math is easy for you, and that won't be so difficult. And maybe your Spanish or Latin, maybe that's easy too. I don't know. But having 2 exams on the same day is going to be a little bit more difficult. And so that's 2 weeks from today. And then you only have 1 exam on 2 weeks from tomorrow, and that would be this one. Got that? And the last chapter that would be on there would be the one that we start today. So we will have a test on this chapter, and it also would be on the exam. And the way you study for my exam is we'll get all the old tests back, and if you could just sit with somebody and go over the old test, you're going to be in good shape. There's no magic there. If you go over those old tests with somebody, you will not be surprised on the test. Yeah.
Can we bring like those old tests home to study?
Yeah. So I just got some file folders, and what I'm going to do is I'm going to put your names on them, and then we'll get those tests, and then maybe every day, maybe starting tomorrow or something like that, I'll try to get a stack and say, here's this test, and we'll just kind of pass those out. And once we get them in the file, they don't belong to you, they belong to me, but you have to give them back to me on the day of the exam. You get that? So if you wanted to study early for chemistry, you could. My own opinion is, if you have the folder with you, then you could decide when you want to study it. Right now, you would have to be careful about making sure you're ready for that exam. Got that? There's 2 exams on that day. But certainly on that weekend or before that, you could decide to study a little bit for that. All right, what do you think? Now, it's unusual this year in that my exam has to be a little shorter for you because there was another chapter we would have normally gotten to, and we also would have done a couple more labs. And because I knew they were going to give exams in December, I postponed some of the labs, and so we at least get this chapter done. And then we will still have about 10 days in January when you come back, and that's still part of the second quarter. So whatever you did on the exam, you still have a chance to make the second quarter grade higher when you come back in January. Does that make sense to everybody or not? I'm trying to lay out a plan. You guys have to think about it like that. Okay, so what we're going to do, please, if you need to talk to me, and you come and talk to me and say, I'm just trying to find a time that I can do this, or I still have some questions about factor label. Can I sit down with you and talk about that? And yeah, I can do that. You want to sit down, Like I get here a little after 7 in the morning. If you want to come at 7:30 or something like that, I can come and see you, or lunch or something like that. If you still want to tackle that factor label. Okay, now the next thing is, let me go ahead and give you your packet today. Oh, here it is. I'd like you to give everybody one of those. And I'll have you give everybody another piece of paper. If you could hand me one of those packets too, Isabel. Okay, now, first of all, this packet is what I'm going to use to teach this chapter with, and we're not going to do the odd questions here, but here's what I'm going to do. If you peel this open, you'll see this part is what I'm using to teach with. And what I did is I found in my file some students who had made some practice tests for this test. And so starting right here at this page right there and going to the end, that will be your homework for this chapter. And you want to get a good homework grade. It helps you, doesn't it? The homework grades are easy. You have to work at it, but you can get a good grade for it. So your homework for this chapter is to, and if you want to tear that off, you can put your name on it if you want to do that, or just keep it together like that. So eventually you'll be turning this in as your homework. Now, because I don't see you on Tuesdays, and Wednesday is a remote day, there are two things I can do. I can do a very small video and have a small lesson on that, and that would be on Google Classroom on that day. Or I could just make you, give you work to do, and you could just do work on that day. They did not want 6 teachers Zooming, having Zoom calls, so that would be difficult for me to do. And so they picked about half of your teachers and said they're going to do Zoom live there, and then the other half were not. And I'm not doing Zoom. So we are going, does everybody understand we're using the Monday schedule? Anytime we're remote, we're going 1, 2, 3, 4, 5, 6. Even if it's Wednesday, you don't go on Wednesday schedule, you go 1, 2, 3, 4, 5, 6. Everybody got that? All right, now, has everybody got that? Can you put that over your nose? Thank you. All right, now the next thing I want to show you is we're starting a new chapter. So everything changes today, and I'm glad. I kind of like doing new things anyway. But since I don't see you on Tuesdays, I'm going to give you something that I want you to do on Wednesday. So on Wednesday, you're going to get a periodic table like this, and I gave you one blank right here. And on chapter 4, let me show you something here. As a matter of fact, you can see the same thing. I just noticed that it's the same picture that is right here. So you can either use the front cover of your book, or if I go to chapter 4, I'll show you it has the same thing on it. Here it is. Here's the same picture right here. Get that? Now, what I may do is part of this chapter, the easy part of the chapter, is knowing the different parts of the periodic table. Now, the first thing I want you to do, and this is not due till Thursday, okay? Okay? You look on this page here, write down page 91 somewhere on that packet. So you're going to be looking at page 91 and page 89. So you're going to go page 89 and 91. All right. Man, excuse me. Okay, the first thing is this chapter, next chapter, you have to know where the metals are and the non-metals. So let's look on this page right here. Now that picture there clearly tells you where the metals are. The metals are all the gray areas, right? And what about the non-metals? They're tucked in this little corner here, and it also includes hydrogen, doesn't it? So let's take a look there. The first thing you're going to do is, for each element, you're going to write the symbol. So let's go ahead and write H here. Now, if it's a metal, you're going to put a little triangle in the upper left-hand corner. But if you look here, is hydrogen a metal or is it a non-metal? Non-metal. So for non-metals, I want you to put it over here in this corner. So you put a little flag in this corner. All right, the next guy, helium. And it's a non-metal, so you put a flag there. Okay, now how do you tell which ones are which? Do you see this little stair step here? See this little stair step right here? And it's in your book also. See a little stair step? See a black stair step? Okay. Boron is clearly a non-metal. But aluminum, like aluminum cans, aluminum is clearly a metal. Now, besides those two, if you're along the stair step, then you are a metalloid, and also called a semi-metal. Now, how am I going to put symbols for that? I want you to put a triangle in both corners. See that? So if you look right here, everybody see the semi-metals? Okay, so let's find them. And they're going to be right here, right here, right here. So silicon is not just a metal, it's both. So I want to put flags on both of those. And then this is another one, germanium. And make sure you write the symbols too. If you would like to do these little flags in a different color, you could do that too. But then I would like you then, that's step one. Step one is where are the metals and where are the non-metals and where are the metalloids, That's step one. Step two, what are the names given to different parts of the periodic table? And again, you can either use the front cover of your book, or you can use this page 89. I would like you to use colors. Use colors, and you're going to shade these in, not hydrogen. You're going to shade all these metals right here in. And what are they called? What would you call this group right here? What is this group right here called? Can you see it? What is this group 1 called? Can anybody read that? It actually has it written right over here. Can you see that or not? Let's see the front cover. Is it easier to see here? What is this group called right here? Can you say that? Alkali metals. So what you would do is, if you want to write it up here, you can, or you could do it here. You could write alkali metals. And then you would use some color, I don't know, blue, red, whatever, and you would slightly shade it in. So it's going to just be a little bit of light color. And another group that they have is group 2. See this group here? See how they use a different color? And the name of that is called the alkaline earth metals. Next, and I don't want you to do it all here. This is homework. All this section right here, these are called the transition metals. So they'll be all the same color. Now, these groups are interesting because the real periodic table, 58 comes right after 57. The real periodic table, you had to cut this right here. You cut the table right there and move all those down and put these 2 little skinny rows in there. And so the element that follows lanthanum, these are called the lanthanides because they act like lanthanum. So this is another color called the lanthanides. Number 90 comes after 89 and comes after actinium. That's why they're called the actinides. So you got alkaline metals, alkaline earth, transition metals, lanthanides, actinides. Now I'm going to come over here. We're almost done. This group over here will have its own color, and it'll be called the noble gases. And then this group here, and that's all the enes, fluorine, chlorine, bromine, iodine, and these are called the halogens. Is everybody okay? We don't have any special names for these, so whatever color you want to put them in, you can. All right, so what do you think? Are you okay on that homework assignment? So the first thing you want to do is you're going to write the symbols, and I can see going right down the line here. I'm going to do all the alkali metals, put their symbols here, put their little flag, put the flag over here in that corner because that's the metal corner. Put their symbols. And then you color it in lightly, and then you're done with that group. And then you do the same thing with this group. And then these are the transition metals. And then here are the lanthanides and the actinides, and they can be their own color there also. Then you have the noble gases and the halogens. Now, we will use that idea in this chapter and next chapter. So I want to give you a homework grade for doing this, but that's not really my lesson today. That's part of the chapter. That's a small part of the chapter, okay? How about some questions? Quick questions about how to do the assignment. Okay, you don't have to turn it in until Thursday, do you? So that's plenty of time to do that. All right, well now what I'm going to do is I'm going to take this packet, and what I'm going to do is I'm going to teach you about the atom. Now, it's possible that you had a certain amount of this in middle school. It's also possible that in 9th grade biology, Miss Frowns, she might have done a certain amount of this with protons, neutrons, electrons. Everybody got that? So maybe you already know a certain amount of this. I'm going to teach it a little bit differently than either one of your teachers did. And so does everybody have this packet now with them? Okay, so here's what I'm going to do. I have a periodic table close to me. Does everybody have a periodic table close to them somewhere? Okay, so what I'm going to do, this chapter has 3 parts to it. Part number 1, they talk about some people and experiments that they did that said, how do we even know that things are made of atoms? And we're going to talk about scientists on another day. Number 2, the bulk of this chapter has to do with the atom structure, protons, neutrons, electrons, isotopes, and ions. That's the bulk. That's what you spend most of your time on. And number 3, the parts of the periodic table. Yes? Yeah, if you may not need it today. I'll be showing it on the camera, but if you want to go get it, you can, but I don't think you really need it. All right, so let's go and as you read this chapter, you're going to find out that at one time, people didn't know anything about matter at all. One time they have a group of people and they sat around and the Greeks, for example, the Greeks said, what do you think things are made of? And they didn't really call it a periodic table, but they had the smallest list of elements at all. And the Greeks would have thought that everything in the world was made of 4 things. So these are the Greeks. And they talked around, they sat around and talked about things. Earth, air, fire, and water. Now, they weren't dumb. For example, they didn't think that rocks were made a whole lot of water, did they? They said if you combine things in the right order, you could get anything. They thought, what is air made of? It's got a lot of air in it, but no earth and maybe no fire. And so they thought everything is only made of 4 little elements, and that was them. As a matter of fact, in the 60s and 70s, there was a black group that was very popular called Earth, Wind, and Fire. Have you ever heard of them? That's a pretty long time ago. Anybody, your parents are real, have you heard of them? Have you heard of them? Earth, Wind, and Fire? Okay. Maybe somebody said, hey, let's name our group Earth, Wind, Fire, and Water. And they said, that's not very catchy. So they just went with Earth, Wind, and Fire. If you Google that, you'll hear some music you might have heard before. All right. And then later, they eventually figured out that things were made of atoms. Here's a person who, his name was Democritus. We'll talk about him again. And he said, hey, let's do Democritus here. Democritus was not necessarily a scientist. He was a person that liked to ask questions, and they like to ask all kinds of questions, but imagine a group of people sitting around and, okay, so you think things are made of earth, wind, and fire. He says, what do you think would happen if I cut this in half, this piece of copper? Do you still think each half would act like copper? And people say, yeah. And they all agreed. Cut in half again. They all agreed to still act like copper. And then because they were philosophers, they said, let's keep cutting in half. And one group said, I think you could cut in half to infinity, and it would still be copper. Well, guess what? I don't see their names in the chemistry book. But it was an idea. It's possible you could have cut that to an infinite number of times and it would still be copper. But then Democritus and the group of people he agreed with, they said, no, I think there's going to be a point where you can't cut it in half anymore. And they had a word, and the word they used was, which meant indivisible. Does everybody know what indivisible means? It's in the Pledge of Allegiance. And when you were a little kid, you probably thought they meant invisible. But what does indivisible mean? Raise your hand if you think you know. Indivisible. Have you ever said the Pledge of Allegiance? You ever say the word indivisible? What does it mean? So I never thought about that. What is it?
It can't be divided.
That's right, undividable. So Democritus had a group of people who said, I don't think you can do that. I think you're going to get to the point where you're going to get this small piece of copper and you won't be able to divide it anymore. And so their group of people said, and the word that meant indivisible was atomos. They thought matter was atomos. That you get to a point where you couldn't divide anymore. And why do I bring this guy's name up? Because today we use the word what? Atom. And we even today, don't we believe that things are made of atoms? So that's why he's in chemistry books, and his name is Democritus. And I'm not going to go through the whole history yet. We'll do a history a little bit every day, but that's enough for today. Eventually, we got to the point where certain people discovered that the atom itself was made of smaller things. So here's a new vocabulary word for you. Watch. What do you think subatomic means? What if somebody said it was sub-freezing temperatures? What would that mean? Delaney, what do you think? If somebody said it was going to be sub-freezing temperatures, what does that mean? Okay, Aurora, what do you think? Sub-freezing temperatures.
I don't know.
Guess? Okay, how about, what do you think?
Like below normal.
You're getting closer. Somebody else. Madison, what do you think? Sub-freezing temperatures. Below freezing. See that? Freezing is like 32 degrees Fahrenheit, right? This week, it's going to get sub-freezing temperatures. When you wake up on either Wednesday or Thursday, it's going to be in the 20s. So sub means below or less than. You get that? If somebody had a subpar performance, that means less than normal. Subpar would be less than normal. What's subatomic mean? It means it's a particle that's smaller than the atom itself. Now, this is where you probably remember from middle school or elementary school. There were three particles that made up the atoms, and they were protons, electrons, and neutrons. Everybody remember that? That's not new, is it? If you wanted to stay in science and you really got into studying matter, there are people with very, very expensive toys. They're called atom smashers. They cost billions and billions of dollars. And what they did is they found out that even protons are made of subprotonic particles, subneutronic particles. And if you do some reading, have you ever heard of anything called a quark? Have you ever heard of quarks? Okay, I've heard of up quarks, down quarks, neutrinos. You ever heard of neutrinos? Anyway, there are people who actually study things smaller than protons and neutrons. By the way, electrons they believe is a basic particle, but they believe protons and neutrons are made of something smaller than that. All right, you okay with these then? All right, now what I did here, this is actually a brick wall, and when I'm teaching this, this is going to be hard for you. I'm going to teach you about what I call the world of mass. If I talk about atoms, I'm going to have times I say, let's just talk about the mass of the atom. And I don't want you to think about anything that has to do with this world over here. But then there'll be a time I'll crawl over that brick wall. I say, let's talk about the world of charge, and I don't want to talk about mass. If you can keep those two worlds separated, you can understand this lesson. We're going to get to this point where we talk about ions and isotopes. And one of them's in one world and one's in another. But here's what's going to happen. If you try to do this, if you try to mix these two worlds together, you'll sit there and say, I don't understand. I don't understand. So in your mind, we're going to build a brick wall. And what I'm going to do is the first lesson today, I'm only going to talk about the world of mass. That's all. I will not talk about plus or minus charges or anything. That's for another day. You get that? So stay with me, and let's take a look. When they, let me see, I think I have this number written down here, if I can find it. Okay, when they were looking at the atom, they found out the atom was made of smaller particles. Now, the proton had a mass of somewhere around like this. I don't have the number written down. Wait a minute, hang on. I have it written down here. I don't memorize the number because I don't need to. There it is. 1.67 times 10 to the minus 24th grams. All right. So how much does a proton weigh? Well, a paper clip, a little regular paper clip, here it is, weighs about a gram. This is a gram right here, okay? There's no way this is close to a gram. You know what 10 to the minus 24th means? 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 1, 6, 7 grams. There you go. That is this number here. Is this a proton? Is it a gram? It's like incredibly small. Is that right? And then they found out that the neutron also had a mass of about that many grams. It was also very, very close to that. It might have been a little bit more, but essentially like that. And you don't have to memorize that number because I'll tell you why. Because chemists were humans. And they could memorize that number. They could. There's nothing wrong with memorize that number. But they did something very human. You know what? I think I want to say that this much mass, which is not very much, I want to call it 1. Yeah. I hereby declare that that many grams equals 1. 1 what? Not 1 gram. 1, I think I'll make up a name. 1 atomic mass unit. 1 AMU. Now, do scientists do this? Yes, they do that. And that makes it simple, doesn't it? So what's the mass of a proton? 1. 1 what? Don't say grams. 1 what? AMU. And what's the mass of a neutron? 1 AMU. I like that. Now, over here, the electron, wow, and I've seen at least 3 different numbers for this. I'm going to write the last one I saw. The last one I saw was about 1/1866th of the mass of a proton. Now, when I put that in the calculator, I get 0.00053 AMUs. Now again, I'm human and so are you. If you look on this periodic table, go all the way to 118, element 118. Element 118, every atom of that oganesson, it has 118 electrons. Now, think about this. I would need an atom that had 1,866 electrons, and then it would be a mass of 1 AMU. Well, who has that? What element has 1,866 electrons? None. I would need 10, 100, I would need 1,000 electrons, and even that would be a half of an AMU. Does anybody have 1,000 electrons? No. So guess what? I'm human, and so are you. When we talk about the world of mass, we're going to say that the mass of an electron will not be counted. We're going to say the mass is 0. So, when I say we're going to talk about the world of mass, you're going to say, oh, you mean protons and neutrons. That's right. That's all we're going to talk about. Now, where do you find protons? And at one time, we didn't know this. I'll talk about that person's discovery at one time, but who have I called on today? Isabella. Where in middle school or elementary school, where did they tell you protons were located? What part of the atom? Did they use a name? Starts with an N. Say it again. Yes? So we know that the protons are found in the center of the atom, the nucleus. And then, who else was found in the nucleus? The neutrons were too. Well, wait a minute. If you think about that, excuse me, any particle found in the nucleus is called a nucleon. If I ask you, say, name the 2 nucleons, that means name the 2 particles found in the nucleus. You say protons and neutrons. Now I want you to think about this, okay? I know you're writing down because you think if I write it down, it might be on the test, but I'm just here to teach. I don't want you to just write things down. I want you to think about this. If electrons essentially have no mass, then you could say that 99.999% of the mass of the atom is found where? Where is 99.999% of the mass found? What do you think? Leda, where do you think? Where would you find essentially 100% of the atom's mass? What part of the atom would it be found in? Okay. Who am I called on? Zach, what do you think? Where would you find essentially 99.999% of the mass? In the nucleus. Everybody get that? So look up here. When I talk about the world of mass, I'm talking about the world of what? The world of the nucleus. Are you with me? And that's what we're doing. As I teach, I want you to stay with me and say, just ask questions. That's all I ask you to do. Now this model here is a one you might have done for Miss Founds in the 9th grade. Did you guys do Bohr models? They were called BOHR. Do you remember drawing energy level, 2 electrons in the first level, 8 in the second? Do you remember doing something like that? She told me she always does that every year. Okay, so what I want to talk about this is a model. Everybody got that? This is a model of the atom. They use it in elementary, they use it in middle school, they even use it in 9th grade. Models always have limitations, don't they? The limitation of this model is it's big enough so you can see the parts of it. Like, for example, these are protons, aren't they? Because they're found in the nucleus and they're positively charged. What do you think these are? What do you think? Kyle, what do you think these are? What do you think? I'll give you a clue. They're in the nucleus, and they're not protons. Okay? Okay, neutrons. Because the only thing found in the nucleus are protons and neutrons. Remember that? Now, you have to remember that. You have to. All right. Now, so what's good about the model is every piece is big enough so I can see it. The real model of the atom, if I did it to scale size, I'd have to go to a Major League Baseball park. And I'd go to second base, and I'd put something about this big, maybe the size of a green pea. I'd put it at second base, and that would be the nucleus of an atom. And all the electrons, which are not in the nucleus, they'd be past the home run fence. Now think about that. The real atom, if I drew it to scale, it would have an incredibly, 100% of the mass is in that little pea, but most of the atom is nothingness. Nothing. There's empty space between the nucleus and the electrons. Now that model won't fit on a book, will it? So I can't put that model in a book. So this is a good model so you can see things. It's a terrible model as far as size. You okay with that? If I drew the atom this big, I could never draw this dot small enough to be the nucleus. Let's move on. Now, one thing is there's certain things about the atom which I want you to know, and they're called alwayses, all right? Now, I want you to look right here in the nucleus. In the nucleus is where you find the fingerprint, the identity. Hey, who are you? What element are you? And let's take a look. It says here that the atomic number, and if you look on this periodic table, you see the red number says 1, 2, 3, 4, 5, 6, 7, 8, 9. See how those? Those are called the atomic numbers. Now, this periodic table puts them in red. This periodic table, that does put it in red. This periodic table puts them in the lower left, and so did that one, but this one didn't. It doesn't matter where they're at. If they see a series of numbers that says 1, 2, 3, 4, 5, 6, 7, those are called atomic numbers. Well, so what? Big deal. It was not random that hydrogen got to be number 1. Hydrogen is number 1 because in the whole universe, the only kind of atoms that have 1 proton in them are hydrogen. So take a look at this right here. How many protons do you see here? Okay, right now I see 3 protons. If I go anywhere in the universe and I find something that has only 3 protons, it must be what element? What do you think? What do you think? If you're number 3 on the periodic table, you have 3 protons, and what element do you have to be? You forget these already?
Lithium?
Yes, very good. And the symbol is capital. Remember, symbols are either 1 capital letter or 1 capital letter and 1 small letter. Does everybody remember that from the first of the year? Now, so now I've identified this atom. This is lithium. Everybody with me with that? Now I'm going to visit the world of mass. I'm still in the world of the nucleus, aren't I? And have this another thing called the mass number. Now the mass number is the number of nucleons, which means add up the protons and the neutrons. So let's take a look. 1, 2, 3. 3 protons. And how many neutrons? 4. So what is the mass number of this atom right here? It's 7. Now stay with me a little bit, because this were, if you had this in middle school, they probably didn't talk about mass number, and they're probably not going to talk about isotopes in the 7th or 8th grade. It's possible, right? So what I'm going to show you here, watch right here. I'm going to go down here, and I'm going to write Li, and chemists designated each of these corners are for information. Now, look right here. In the upper left-hand corner, if you write something, if you write Li, and if you write something in that corner, I know you mean what is the mass number. So what is the mass number of this guy? What do you think? Sierra, what's the mass number of this atom? See this atom? What's the mass number? 7. Now, the upper left-hand corner is designated for you to write the mass number of that atom. Is everybody with me? We're still in the world of mass, right? The world of nucleus. The lower left-hand corner, you can write the atomic number. The atomic number is the number of protons. All right, not bad. And so if you ever see that in a book, you know that that means he's really number 3 on the periodic table. He has 3 protons. And you know this is the number of things in a nucleus. Now, a little bit of thinking. Not much. A little bit. Ready? 7 things are in the nucleus, and 3 of them are protons. What would you get if you took the mass number and subtracted the atomic number? What would you get? Who am I calling? Julia, I'm calling you. Julia.
If you subtract the bottom from the top.
Yeah, take 7 minus 3, and what would that give you? 4 what, though? This is how many things are in the nucleus. This is how many things in the nucleus are called protons.
Would it be 4 protons?
Say what?
Would it be 4 protons?
Oh, you're close, but this is protons. 3 is protons. Here, what if 7 people came to the party and 3 of them were boys?
So the rest are
4 were girls. Okay. There's 7 things in this nucleus, and 3 of them are protons. The rest of them must be what? Neutrons. Ooh, I could find out how many neutrons this guy had by taking this number minus that number there. Are you with me? I was upstairs somewhere. All right, what do you think? All right, we're still in the world of mass, okay? Let's turn this over. Now, I think you'd agree that all 3 of these are 3 different atoms. They don't look the same, do they? What I'd like you to do is take about a minute or so. I want you to fill in the atomic number for each one, the mass number for each one, and the symbol for each one. Let's do that. And you can flip back and look at your notes. With the atomic number for each atom, the mass number for each atom, and then the symbol for each atom. And if you're having a lot of trouble, you're not paying attention. okay? If you're having a little bit of trouble, you go back and look at your notes. And that would be normal. It'd be normal to have a little bit of trouble. How we doing? All right, let's see. We got it called on for a while. Okay. Madison, here we go. Madison, when you look at this model, this atom, what atomic number do you think you should give it? 1, because of 1 proton. What about this one, though? Yes, because it only has 1 proton. And what about this one? You're correct. All right, let's jump to Isabella. Isabella, what mass number would you give this guy? What now?
1.
Yes, because in the world of mass, electrons don't count. What mass number would you give for this one?
2.
What about the next one? Excellent, excellent, excellent. Okay, Sierra, here we go. Here's the hardest question, Sierra. What symbol are you going to give this guy right here? I'll give you a clue. It's got to be one of these up here. Say it again. It is. Now this one. Okay. How many protons does it have? 1. What's its atomic number then? It has to be. How about the third one, Sierra? Yes. Now, one more thing and we'll be gone. Watch now. Wouldn't this be confusing for anybody who had 3 different atoms and you had the same symbol? So we have to fix it. As soon as somebody answers this question, tell me how to fix it, you can leave. If you're going to wait here 10 minutes, we'll wait here 10 minutes. I want somebody to fix this. How do I fix these symbols so I know that you mean this one versus this? Raise your hand. Everybody will like you because you'll get out of here. How do I fix it? What? Where? Here? No. Here? 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 Where do you want it? I'm waiting. Tell me how to fix it. Lower left or upper left? Oh, upper left. What do you want to put there? You're right. This mass number is 1. What about here?
2.
Yes? And last but not least, what do you call atoms of the same element that have different masses? What are they called? All right, see you. Thank you very much. I won't see you, so always watch on Google Classroom. I actually give a summary of every day. It always gives the homework and tells you what we do every day. If there's a video, it's on there. So be watching for Google Classroom. It'll remind you what to do on Wednesday, all right? All right, thank you. Don't forget now, if you need to fix your factor label, that's something you have to do. I can help you a little bit.